We'll now move on to Rick Tofani. He's out of SAIT. Let me just, sorry about this. He's the Director of Applied Research at SAIT. He has about 75 scientific staff and administrators covering 6 key research themes in green buildings, UAVs, prototyping, electronics and software, environmental technologies, and alternative energy technologies. Rick has been in the applied research business for about 30 years now and started his career many years ago in potash and coal mining, specifically in mine design. Thank you, Rick.
Thanks, Larry, and good morning, folks. I feel a little bit intimidated by what I just saw from Jason with the basic research that he's doing in the creation of instrumentation. We tend to be a little bit more applied in our group. So, you know, some of our typical work includes figuring out the grade of duct tape to use to tape a FLIR meter to the bottom of a UAV, but we come out with great instrumentation anyway, or just the same. No, I'm just kidding, of course. But yeah, it's great to see some of the instruments that you're working on and things that are getting developed here in Alberta. It's really a good sign for us. So I hope that just by clicking a button, I can go to the next slide. Maybe the folks at PTAC can move me to the next slide. Oh, there we go. Anyway, okay, got it at this end. So just to give folks a bit of an overview, applied research at colleges has been around in Alberta about as long as I've been around in Alberta, about 20 years. At SAIT, it was created and started in 2005. And really we're driven by industry projects. So we don't have any researchers that are doing their own basic research. Every project that we have has to be tied to an industry partner. And the other key is that it has to involve a student. Not always, but we do our darndest to make sure a student is involved most of the time. So we have about 55,000 square feet of space that's been dedicated to ARIS people here. At SAIT on the campus in the city, a couple of labs at the university, and a couple of labs down south at Point Trotter, which is almost in Lethbridge. And as you heard, 75 staff. We also have a CFRAF program with the university where we're developing prototypes beyond the bench for U of C researchers. And currently, as an example, we're working on the, I'll call it the natural gas device for Proton, one of Ian Gates's companies, and the 200 barrel per day bitumen bit machine, also for one of Ian Gates's companies. And we manage about 80 to 100 new project inquiries every year. And for those of you who haven't seen it before, a PIF is just a project inquiry form that comes in from a client who wants to undertake a project with us, and it's a non-confidential disclosure. So those are the 6 areas. I don't know if this is just me or what, but hang on. It's my nervous finger, I guess. Okay, good. So these are the 6 areas that we work in. And recently we have approval from CFI and hopefully shortly from NSERC to create a brand new additive manufacturing center, which has an impact on all of the other areas that we work in, because that additive manufacturing center will provide us with metal 3D printing capabilities and 5-axis milling that allows us to make really unique parts for a lot of the equipment that we develop for our clients, including aircraft parts, which is an area that we want to get more and more involved with the likes of Viking Air and even Bombardier and Boeing. So the folks that are working in the GHG reduction area at ARIS myself, Dr. Vida Martez, who runs the OTSG lab, that's the once through steam generation lab, and is also doing work in alternative energy. Dr. Ken Whitehead, who runs the unmanned aerial vehicle lab, and Ken Omatani, who's running the design, testing, and fabrication lab, and has also got quite a cool little area going in fuels testing. We have been lucky enough to receive funding from CanERIC, where we've purchased equipment and we're using it. We'd very much like to work with others in our network and continue to collaborate. In Dr. Vida Martez's area, she's currently working, of course, on once through steam generation, where we're analyzing fouling and erosion and corrosion in the OTSGs. And the whole notion there is to reduce the greenhouse gas impact, find ways to collect the energy and the heat that's provided by OTSGs, and just make them operate much more efficiently. But she's also working with solid oxide fuel cells in creating energy from some of that heat, or creating energy from methane that's coming off of wells. So we've got some solid oxide fuel cells in the field up north at Grand Prairie at some gas well sites that are running quite nicely. In Dr. Ken Whitehead's area, we know that he's working with UAVs, as most of you know, and some of our partnerships there have been fairly significant. So just going back to high temperature, high pressure work, fouling, erosion and corrosion, process optimization, and this project is sponsored by COSIA, NSERC, and Alberta Innovates. So just to give you an idea, OTSG is on the left, full size, OTSG on the right, lab size. The difference is on a scale of how much water is used, it's about a 1/1000th scale. In our OTSG, we use about 1.5 liters of high pressurized water, highly pressurized steam, but it starts off with about 1.5 liters of water. And so far, the results that we've been able to produce, according to our COSIA friends, replicate very nicely conditions in the field. Another view of the same OTSG, the horizontal piece in the middle, it's all wrapped up, is the actual steam tube configuration that simulates what's going on with the, 5 kilometers of steam tube in a typical OTSG. This equipment was built at Inotech, and it came from a prototype that was developed in Bartlesville, Oklahoma, and we brought it here about 2.5 to 3 years ago. So the work that we've been doing in fugitive emissions in the UAV area took us to begin work with the Jet Propulsion Lab at NASA. We were successful in asking and getting one of the research scientists whose device was put on the Mars lander to come and turn that device into a more commercial unit that could be used in the field and research. And he has gone on to begin to commercialize that through a private sector company. But we were basically tasked with developing a user-friendly platform that could identify leaks and begin to estimate volume. And as well, that same instrument was being used by a group in BC out of, I think it's SFU, could be wrong. And I think even maybe Dave Risk may have had it in his hands at one point in time as well. So it's had a good cross-section of users here in Canada to help them get to a more commercial instrument. But it was instrumental in first, pointing out that the instrument itself was very successful in finding parts per billion in terms of leaks at gas sites here in Alberta. Sorry about this. So this is just a picture of the unit that we were using. We had to figure out how to put it on the bottom of an M600, keep it balanced, have a small weather station on there as well, and make it work, and then configure the system so that we could collect data from the unit while it was flying, downloading to a cell phone, high tech, you know, and collect information in the field. And we're still using this instrument, but some of our activities in the past few months has been directed towards using UAVs in the COVID area. So the amount of methane work that we've been doing has been restricted to Kirk and CMC's project down in Brooks that I'm sure Kirk has talked about. And then one of the other things that we do that I'm particularly proud of is helping entrepreneurs with technology. Clean O2 is a company that was started by basically a furnace repair guy who graduated from SAIT, wanted to figure out how to take flue gas from smaller sources and turn it into something useful. And he basically built a device, and he almost blew himself up, that he attached to a furnace to capture flue gas using sodium sulfate or sodium carbonate, and turn the resulting product into a fertilizer from the flue gas. So we basically helped him do that by building this particular instrument. On the right of the screen, you'll see the home size device. On the left of the right-hand picture, and on the right of the picture is the full-size device. And he's been selling these to various industrial and home users and trying to figure out the actual business plan because obviously you've got to go around and collect the fertilizer. So that's also what we do in our group, is help to build the actual prototype, whether it be something that looks like this or something that looks like one of Dr. Olfort's instruments that he has commercialized. So that's just a list of the instruments that we purchased using our CanERIC funding. And we really didn't tape the FLIR camera to the bottom of a UAV, but I was asked if we could do that because researchers are researchers. And there's my contact info if you have any questions. Thanks.
Thank you, Rick. I'll open up the floor to questions. Okay, well, I'll just have a couple of comments. I'm glad to see JPL and NASA's logos on your presentation. I think that's pretty cool. And you are the king of collaboration, so thank you for that. I think CanERIC really benefits by your leadership in that regard. So thank you, Rick.
Sure, thanks.